Transformers are devices that change the voltage of an alternating current supply. An alternating current supply. They're used throughout the electricity system in all countries, from the power plant, which generates the electricity at about 25,000 volts from the generators. That's fed into transformers, which then step up the voltage to 400,000 volts, 400 kilovolts as the maximum transmission voltage in the UK. There is a reason for that, and that's to stop heat losses in the cables as that electricity is transmitted many kilometers across the land. When it finally reaches the town or the city, a substation will step down that voltage from 400 kilovolts to a much lower voltage. Now, domestic voltage for homes is 230 volts, so a big step down from 400,000 to 230 volts. There is an intermediate step which is for industrial use, but we'll just look at the domestic household voltage, which is 230 volts, and that's safe for us to use in most of our appliances. But some of your appliances can't use 230 volts, so we need transformers again, for example in a phone charger, to transform 230 volts from our house sockets to, let's say, 9 volts for your mobile phone charger. And that's why transformers are so important. So, if the transformer increases the voltage, it is called a step-up transformer. And guess what? If it decreases the voltage, it is called a step-down transformer. Step-up transformers are used just after the power station to step up the voltage to 400,000 volts for transmission across long distances. So, what would a labeled diagram of a basic iron core transformer look like? Here's the idea. We have two coils, a primary coil and a secondary coil. So this is a primary coil, and here is our secondary coil. They're both wound onto an iron core, a transformer core. And the reason for that core is to strengthen the magnetic field that's created when we feed an alternating current into the primary coil. So here is our input voltage. Our input voltage. We can call that VP for primary. And that input voltage, which is an AC current, it's going backwards and forwards, will create a magnetic field in this coil. That magnetic field is trapped mostly in the iron core, because iron is a very good magnetic material. So this would be a magnetic field which is constantly varying backwards and forwards. It's collapsing and growing, collapsing and growing. And the secondary coil experiences that magnetic field as well. So the secondary coil, which here are the outputs, will have that magnetic field cutting through the coils and therefore inducing an EMF. This is electromagnetic induction again. And an EMF is induced in that secondary coil, and if there's a circuit, we can create a current. So the EMF produced is the voltage, and we can call that the output voltage, or VS for secondary. So this is the output voltage, and this will also be alternating current. So everything is growing and collapsing up to 50 times a second from the input voltage, which is an AC supply. Magnetic field is growing and collapsing, inducing a voltage in the secondary coil, which creates an AC backwards and forwards voltage in the external circuit there. And that's the basic idea of a transformer.